Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. Now here it is given that you are standing on the edge of a cliff which is 30.5 meter high. So this distance is 30.5 meter high. Now you drop a ball from the cliff, from the edge of the cliff, and later you drop another ball from this same edge with the initial velocity 11.2 meters per second. So let me write here, this is case, there are two cases here, case 1 and case 2. Now in case 1 you dropped a ball with initial velocity equals to 0, and in second case you drop a ball with initial velocity 11.2 meter per second. Now there are two parts in this question that we need to solve. In the A part, we need to tell which ball has a greater increase in speed when it reaches to the base of the cliff. So this is the base of the cliff. So let us solve A part first. Now we know that speed increases linearly with time in the case of free fall, but non-linearly with distance. Now because the first ball has a zero initial velocity, so after reaching to the base of the cliff, the average velocity for the ball 1 would be less, and the average velocity for the second ball would be more, because initial velocity, this is V0, is 11.2 for the second ball, so average velocity would be more here. That is what we can conclude from here, that the first ball will travel for a longer period of time to reach to the base. Therefore the increase in speed will be greater for ball 1. And we can also prove by using equations. This is what we have to verify in part B, that how the increase in speed for ball 1 is greater than the increase in speed for ball 2. So for that we can use this equation. V square is equals to V0 square plus 2a delta x. Now we are taking downward direction to be positive, so in this case a would be positive g. Now let us find the final velocity for ball 1, that is case 1. So for case 1, v squared, that is the final velocity, will be equals to, now initial velocity we have 0 for this one, so this is 0 plus 2 times, now a is g here, so 9.81, and delta x we have 30.5 meter. Now this is v squared, so we can write this way under root, and we'll get this answer to be 24.5 meter per second. So this is the final velocity for the ball 1. Similarly, we can calculate the final velocity for ball 2. So this would be under root, same equation we can use. Initial velocity this time it is 11.2 meter per second. So this is 11.2 meter per second plus 2 times g is same, 9.81 meter per second squared, and delta x is also same, that is 30.5 meter. Now we can solve this and we'll get this answer to be 26.9 meter per second. Now if you calculate the change in speed delta v for ball 1, this would be equals to v1 minus v0 for ball 1. So v1 we have calculated to be 24.5 minus initial velocity for the ball 1 is 0, so this is 0, so this is 24.5 meter per second. Now the change in speed for the ball 2, this would be v2 minus v0. v2 we have calculated to be 26.9 meter per second minus, now v0 for ball 2 is 11.2 meter per second, so this is 11.2 meter per second, so this would be equals to 15.7 meter per second. Now here it is clearly visible that the increase in speed for ball 1 is 24.5 and increase in speed for ball 2 is 15.7. Therefore we have verified that the increase in speed for ball 1 is greater than the increase in speed for ball 2. Now here I did a mistake. It should be square here because this is V0 square. Now rest answer would be same. We'll get 26.9 only, and this would remain same. So here in this question it is given that you are riding on an elevator which is descending at a constant speed of 3 meters per second. That is, this elevator is moving downward with velocity 3 meters per second. Now accidentally you dropped a book from your arm, and there are two parts in this question that we need to solve. In the A part, we need to tell how much time does it take for the book to reach the elevator, which is 1.2 meter below your arm. So this distance is given to be 1.2 meter, and we need to calculate the time taken by this book to reach to the floor of the elevator. Now suppose a person is watching this motion from outside the elevator, so he'll see that the elevator and you and all that stuff in the elevator is moving with a velocity of 3 meter per second in the downward direction. But if you see the motion from your point of view, then you will see that the elevator is at rest, and when you dropped this book, the book was at rest. So initial velocity for the book will be 0, and we are taking that this is our positive x direction, and this is the floor of the elevator. So this is the final position xf, and this distance we are given to be 1.2 meter, and this is the initial position for the book. Let it be x0 equals to 0. We're going to solve this question from your point of view, not from this person point of view. We'll be solving from your point of view. Now we're going to apply this equation, which is x is equals to x0 plus v0 t plus half at square. Now initial position is 0 for the book. Initial velocity is also 0. So we can write that x will be equals to 1 over 2 at square. Or from here we can write that t would be equals to under root 2x divided by g. Now since we have taken this our positive direction, so in this case a would be equals to positive g. That is why we have taken a as g here. Now we can put the values to find the answer. So under root 2 times the final position is 1.2 meter. So 1.2 meter divided by g is 9.81 meter per second squared. Now from here we can find the time taken by the book to reach the floor would be 0.49 seconds. So in just in this much time the ball reaches on the floor of the elevator. Now next in the B part we need to find the book's speed relative to you when it hits the elevator floor. It's very simple. We can use this equation. V is equals to V0 plus AT. So V0 is 0. A in this case is G, which is 9.81, and time is 0.49, because we need to calculate the velocity of the book just when it reaches the floor, and time taken by the book to reach the floor is 0.49. That is why we have plugged this value t as 0.49 seconds here, and this is in meters per second squared. Now you can solve this by using a calculator, and we'll get this answer to be 4.8 meter per second. So this is the velocity of the book relative to you, because we are solving this question according to your point of view. So this would be the answer for the B part. Now I'm just extending this question. Now suppose you need to calculate the velocity according to this person, from this person point of view. Then what would be the velocity? Let it be V1. So according from this point of view, from this person's point of view, the velocity would be 4.8 plus 3, because the elevator is moving in the downward direction with speed 3 meters per second. So that would be 7.8 meter per second. Or in the coming chapters we'll see that this is nothing but the absolute velocity, but not now. We'll study in the later chapters.